first talk is from a couple of friends at Igalia, past and future of server-side runtimes, from Andreu Botella and Nicolò Ribaudo. Please come on stage, guys. And don't trip yourself. Great, folks. And yay, go for it.
I'm Nicolò, and they're Andreu.
Hi.
OK, yeah. So as Matteo said, we'll be talking a little bit about the past and future of server-side runtimes. Well, does this work? No. OK. And well, like we are not conf, we'll know what server-side JavaScript is. And like nowadays, we have so many different server-side runtimes. Like there are a bunch of them, but there are new runtimes coming up every couple of months. But like let's look at the original one. That's not Node. Like if we look about what there was before Node, we see that JavaScript was run on the server since like basically when JavaScript existed. Like those are two examples, like Livewire from Netscape or others. And like nobody talks about this anymore, but like they were like the engines that first brought JavaScript to the server. And they had all something in common that were completely different from like how Node.js is nowadays and how all the other runtimes work. They were more similar to PHP, maybe. Like you were embedding some JavaScript in the HTML, and like that was then executed to replace some pieces of the HTML. You had one thread per request, so you didn't have to worry about like handling requests asynchronously. You just had your HTML file with some JavaScript. The server was running that file in a thread synchronously and like getting the result at the end and sending that to the browser. And they all provided utilities like for file system, for databases, and like trying to write that is actually like trying to write code in like PHP, as I said. But like let's look at a concrete example, Jaxer. It was created 15 years ago by a company called Aptana. They now work on editors. It's not maintained anymore. And originally it was closed source, but when they stopped maintaining it, they published the code on GitHub. I tried building it to try to get it running. Good luck with that. I couldn't figure out how to do it. However, they have a website that's not available anymore, but it's in the Internet Archive. And I managed to download the executable and try to get it run, because it was fun. Like my first server-side runtime was Node, and I wanted to know what there was before. And we actually have it running here. Like I have a Windows machine, and like we can see how JavaScript looked in practice. I have this very small application. It's basically all client-side. Let me reload. There is a button just to increase a number. And like this is all client-side. If you look at the source, we can see that like there is my empty H1 element with the JavaScript code that's then populating it and updating when I click the button. Like what if I wanted to move some things to the server? Like this is obviously not a realistic example, but like it gives the idea. Well, in all of them, there was some way to mark where script tags had to run. So, thanks, VS Code. So like I could split my logic in two, because like obviously click handlers need to live on the client, but like some logic could run on the server. Specifically for Jaxer, I have to say run at server. Depending on which one you use, there was a different way to mark code. Well, this uses jQuery, so I need to also run jQuery on the server. And it always worked. I just have to say, I want to run this bot on the client and the server. And all these runtimes were basically just running a browser engine. So HTML was there, and all the front-end libraries could already work server-side. So let's try running these, and let's see if it still works. Yes. And now like it looks exactly the same. But if we look at the HTML code this time, sorry, it was too small before. If you look at the HTML code this time, now this 7 is like server-side rendered. I'm requesting this to my app, and the engine is working there. And they have utilities like to read files. So here I could read this from a file, for example. There is a jaxer.file.read API, and I pass the file path. But as I mentioned, everything here is like, they didn't need to worry about asynchronous code, because it was a single request per thread. So if I want to run this in a set timeout, for example, well, let's say 100 milliseconds. And I try to see the result, this just doesn't work. This coordinate timeout never runs because, well, because it finishes running JavaScript code, it takes a snapshot of the HTML, and it sends it to the browser.
You should try 0 also. Timeout or 0.
Oh, yeah, I mean, timeout is always asynchronous, even if you use 0, so it still doesn't work. So, like, it was JavaScript, but with some limitations. And then we had all these, like, runtimes, and then Node came to change, like, to change the paradigm.
Yeah, so in just the span of in the short span of a few years after Node.js was released, it quickly became the go-to server-side platform and pretty much overtaking all of the previous runtimes that we saw. And I want to explore why. It's obviously not because you had the same language as the client side, because all of these previous runtimes also had it. So in order to understand why, we need to take a look at the state of HTTP servers around 2009. The dominant server, by and large, was Apache, which used blocking I/O with threads. We'll dig a bit deeper into that in the next slide. And there were two main kinds of server-side languages, two main categories. One was PHP, ASP.NET, anything that was using CGI and fast CGI, which had a separate execution for every request. And if you define a global variable or something like that while processing one request, it will not be available at the next one. And it used blocking I/O. Then there's things like Java and Ruby, which usually spin their own, they spin their own servers, usually with some framework to not have to worry about the server code itself. And they use blocking I/O with threads. If you notice, Jaxer and this previous run in servers, like JavaScript runtimes, were in this first category with PHP. And all of these things, all of these servers and server-side languages basically struggle to handle many concurrent many concurrent connections. At 10K, this became a problem. It was starting to become a problem at that time, and it was called the C10K problem. So the reason for this is that blocking I/O is the default kind of I/O in most languages and operating systems. And I/O is incredibly slow from the CPU's perspective. And network requests are slow, but even file reads can take thousands of CPU clock cycles that could be spent on something else. You can use threads to continue processing tasks at the same time that you're doing I/O, and this is what servers had to do to not wait so long for the I/O. But starting a thread takes some amount of time. Each thread takes a fixed amount of memory, like the stack. You can reduce the size of the stack, and they all suck up. And once you have a lot of threads, and even across many processes, the OS task scheduling slows down because the operating system has to figure out how to share the actual cores across the threads. For a server to continue accepting connections, it needs to have at least as many threads as concurrent connections at this point in time. It usually needs, it usually uses more because of thread pooling to avoid having to start a thread every time. But with enough concurrent connections, the OS just can't keep up. So what if you could tell the OS to start some I/O, but not block? The OS could have a queue of input-output messages. It just pushes to that queue whenever some I/O operation has finished running or there is some update. And you would call a function that would get you the next message in the queue. Your application code would run inside a loop in response to these I/O messages, in response to these events. And this is what an event loop actually is. JavaScript developers the term is a bit opaque to JavaScript developers, but it is simply this kind of loop and the JavaScript code running inside the loop body for each of the kinds of events. And there are some complications with microtasks, the Node.js event loop, but those are all things that go inside the loop body, pretty much. And even a single-threaded event loop can easily be way more performant than blocking I/O and threads if your code does not do heavy computation, if it's mostly using I/O. And Node.js was a runtime that intended to solve this problem. And it did so by using JavaScript, which was designed for an event loop. So it was used in the browser in an event loop. Most JavaScript developers were used to that. And so Node.js was used something that Ryan Dahl later called force optimization, by forcing the developer to be in an environment in which there is no blocking I/O. You're forced to run inside this loop, and this was done that way to force the developers to have performant servers. There's no blocking I/O until Node in Node 0.1.30 introduced file synchronous I/O. Oh well. But why it's required only synchronous then? Because Node still has asynchronous file.
Yeah, like if Node want to have everything async, why this happened? Well, the reason is standards. How many of you know what server.js is? Okay, well, it was renamed shortly after being created. So how many of you know what CommonJS is? Actually, are you sure? Spoiler, it's not just a require. And like, even if now everybody thinks about require when thinking about CommonJS. It was an effort to standardize server-side platform started around 2009 because shortly, very close to when Node was released. And it was started by Mozilla Employer. And the need for this was because JavaScript was highly fragmented. There was no shared libraries for AI operations, no shared way to load other files. Many platforms could run browser code, but then you still needed all the platform-specific code. Or Node was not compatible with any of the other platforms. So there wasn't really a JavaScript ecosystem. You had separate ecosystems for all of the platforms. And there are multiple efforts that started within this CommonJS label. Well, the one that we'll know is modules. Modules were different in every single place. In some platforms, you could use script tags to include them, or you have some in Juxta, for example, you had this load function that just injected a file in a global scope. In Node, you had require and include. Include was modifying the global scope, and they were asynchronous. There was this onload callback, and after that your require call was done, the onload callback would be fired. So there is this proposal within CommonJS called CommonJS Modules 1.1.1 that wanted to fix this problem. And if we read at the spec, it's exactly what we know today. There is a require function that accepts the name of a module, returns some API of the imported module, and then in modules we have a require variable and an exports variable. And there were multiple implementations, such as Narval. It was a platform that could run within other platforms to provide a shared CommonJS environment. And at some point, also Node.js implemented this, and that's why nowadays require is synchronous and not asynchronous anymore. Maybe having require asynchronous would have helped today with migrating to ESM. And there were also some attempts to make them work in the browser. AMD, for example, came out of this effort, but it ended up not working very well because it had more restrictions than just running CommonJS on the server. And something else that came out of CommonJS is asynchronous interfaces. Node, and we now use none of those proposals, but if you try to read the promises A spec, you see that he provides a then handler, which takes a bunch of callbacks. And this is very similar to what we had today. This was then evolved into promises A+, which was eventually adopted by the ECMAScript standard. And fun fact, it was suggested already in 2009 that Node should have supported promises rather than callbacks. And as we know, it didn't happen. Promises seem to be quite heavy syntax. Also, promises were very different from what we have today, so it's probably for the best that this didn't happen. Otherwise, we might be stuck with a worse version of promises rather than the good one we have now. And there were many other proposals within CommonJS. For example, the assert module in Node was original aligning with assert as defined by CommonJS. It also tried to standardize console because at the time every browser had a different console interface and all server-side environments had a different one. So many of the methods on console we have today were part of the CommonJS standard. It tried to introduce workers to the server and like other proposals that like were then never implemented in other various platforms. So why we don't hear about all these proposals anymore? Well, the reason is that Node won. Node won, and like everybody was using Node. All the other server-side runtimes stopped being used, and you don't really need a standard where there is a single player.
But that was 10 years ago. Things have changed a lot since then, and now there are a lot more JavaScript runtimes with a focus on web interoperability. So why should you care about web interoperability? Well, it lets you reuse code between the server side and the client side. Just like if you just use APIs that are common, then you don't have to you can just reuse the code. You don't need to use polyfills like isomorphic fetch. The learn once, write anywhere. The developer muscle memory. You have a single common documentation that you can just look on MDN, and even if you're using, I don't know, fetch on Node, and having runtimes be interoperable with the web means they become interoperable with each other, which reduces lock-in. So Node.js, well, in 2009 when Node.js started, the web had very few non-DOM APIs. And the focus of Node.js in the beginning was not to be web compatible. But still, it supported set time and set interval from the very beginning. And console.log was supported since version 0.2 in 2010. Now, over time, along the history of Node.js, the web gained many web APIs that could indeed be used in the backend. And Node.js was a bit slow to adopt them, but it is finally getting there. There was ESM, which is now finally supported by default after so many years in progress. And there has been a shift in the ecosystem. There are newer runtimes, which all take after Node in that they all use non-blocking I/O in an event loop in the same way. Like, that really changed the game. They usually have some extent of compatibility with Node.js and NPM because of the sheer amount of packages that rely on that. They use ESM by default, like really adopting that standard. And they are heavily invested in web interoperability. But it's interesting to see that modern runtimes and cloud platforms bring new uses to existing web APIs. If you use Cloudflare workers or well, Deno.serve, you have HTTP fetch handlers that take in a request object from the fetch API and return a response. This is similar to the service worker API in browsers, but it's not the same. And it's being used for fetch handlers is new. Deno also supports server-side local storage, which is something that, well, it's a new use for that. And I find it very interesting that Deno deployed Deno's edge platform uses broadcast channel, which in the web is an API to pass messages across same origin tabs and so on. It uses it for passing messages across instances of an application in different edge servers. So with broadcast channel in the web, you can transfer shared array buffers, but that needs to be the same process. You can do that for edge servers. And one of the things that summarizes this focus on web interoperability and the value that it brings you is a quote from Luca Casonato from a blog post about WinterCG. When using Deno, or Bun, or Cloudflare workers, you aren't learning new platform-specific APIs or functionalities. You are investing in your knowledge of the largest and most important platform in the world, the web. Now, there are a few challenges. The differences between server-side runtimes and browsers do matter in terms of support for web APIs. The web specs are written for browsers. They don't take into account server-side needs very well. And if each runtime solves these issues independently, and even if they show up to talk with the spec folks independently, well, we have new sources of incompatibilities across the engine. And in terms of trying to see the spec cater to our needs, if we show up independently, they will not listen to us as well as if we join together. So server-side runtimes want to extend new APIs in ways that aren't priority to browsers, as we kind of see here. And in general, we don't have a standards body which is specific to server-side runtimes. So in May 2022, engineers from various server-side runtimes, Node.js, Deno, Cloudflare Workers, and other companies involved in that space like Bloomberg and we at Igalia, created the Web Interoperable Runtimes Community Group, aka WinterCG. WinterCG is a venue for coordination across various server-side runtimes. It focuses on interoperability across the various runtimes and with browsers. It also tries to coordinate various proposals to add things to the web and JavaScript APIs that will benefit server-side runtimes. And it also makes, this is something that we established as of last week. We also now have a process to make some APIs which are not web APIs interoperable across server-side runtimes. We propose changes to existing specifications and plan to upstream them. We incubate, we start working on other specifications, which will then end up moving to another standards body and publish there. And WinterCG is open for everyone to participate. You can join the meetings and so on. We try to define a common set of APIs, try to identify current gaps in runtimes. Basically, we try to define a comprehensive baseline that you can write interoperable code against and to reduce locking. So we're working on various things, including a common minimum API, which is basically a subset of web APIs which should be implemented across the board in WinterCG compliant runtimes. It kind of defines what WinterCG compliant is. This is still being worked on, but we have a set of APIs and yeah. The WinterCG fetch spec, which is the spec that defines fetch for browsers, doesn't fully fit server-side needs. You have same origin restrictions with cores and so on. Cookies are not exposed on the browser. You can get a cookie or set a set cookie header because there are HTTP-only cookies, and exposing that, the browser does not expose that, but in the server you don't have a cookie jar, and you need that. And it is very interesting for servers to for server-side JavaScript to support full duplex request streaming, like sending a streaming request before the receiving server starting to receive the response, before before you fully send the request. And this is something that browsers do not support or plan to support, and that would not just supports it, Deno supports it. It's so here we're trying to define. We have a fork where we're defining requirements for different kinds of runtimes, like some requirements for browsers, some requirements for server-side runtime, and the intent is to upstream those changes to the WinterCG spec. We have async context. This is basically like Node.js async local storage, but integrated with web APIs. We're running this as a stage 2 TC39 proposal. If you want to know more about async local storage, Steven Bellinger did a talk about this on Monday, and Dan Ehrenberg will be talking about async context, about why it can be polyfilled in userland, why what we're doing in the spec side later today, if you want to learn more. There's Sockets API, an API for various connections, similar to net.connect, Deno.connect. James and Aaron Snell talked about this on Monday. The intent is to be server-side only, but there is the open question that it could be useful in PWAs in the browser. And then there are some other things that we're working on, like web crypto streams, like having encryption and hashing capabilities in a streaming manner. We're working on defining what package.json means. Then there's runtime keys, which is for conditional exports in package.json to define the various names for various runtimes. And well, in conclusion, early server-side runtimes failed because they stuck to an outdated model, which was blocking I/O and no event loop. And nowadays, the outdated model is to rely on runtime-specific APIs for functionalities that also make sense in browsers. The web is not going anywhere, and it makes sense to bet on it. And it also makes sense for runtimes to push the web forward. And it makes more sense that having Node.js compatibility in all those runtimes. So come work with us. We're wintercg.org. All the development happens on GitHub. Join our Matrix room and our monthly calls. Yep.
All right. Thank you, guys. Unfortunately, we don't have time for questions, but if you are interested in talking more about WinterCG, stuff like that, definitely pull the guys aside. I'm one of the co-chairs of the group, so this is a topic near and dear to my heart as well, so I appreciate it. It was a great talk. Thank you, guys. Okay, so while we're waiting for the next speaker to come up, Gil, you...